The disc substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice into which the transistors will later be fitted. Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of light. The silicon disc is spin-coated with a photosensitive resist. UV light transfers the circuit structures imprinted on a mask to the wafer. The exposed parts of the resist are soluble and are removed by developing fluid. The transferred structures can now be used as a template. The unprotected parts of the wafer surface are etched away. The structures of billions of small current switches are generated on each wafer. Silicon is a semiconductor, which means that its conductivity can change via a high-precision emplacement of so-called dopant atoms. Dopant atoms are shot into the silicon structures. Initially, these atoms are distributed unevenly in the silicon lattice. At high temperatures, the dopant atoms become flexible and take over a fixed position in the atomic structure. Copper dominates the next process. Finest interconnect wires link up billions of separate transistors to form integrated. Before the copper is poured into the trenches for the interconnects, a barrier layer is applied. It helps to prevent short circuits and guarantees reliability. The trenches are then filled with copper. Finally, the excess copper is ground down to the edges of the trenches. This insulates each interconnect from the others.